Hey guys, today's lesson we're going to talk about looking at the different graphs and tables of different types of functions. So I'm actually going to have you do this first part right here on your own. It says, for the following functions, create a table and graph each function in a different color. So notice they've already plugged in the x values. So I want you to plug each of these x values into these respective equations and fill out these boxes. Okay, and then you'll have an ordered pair. Use each ordered pair to plot points over here on the graph. Okay, and it says different color. So you should have 3 different colors. So pause the video and do that part right now. Okay guys, so this is what your table should look like and your graphs. So you may need to make adjustments to your graphs or your table, and if so, pause the video and do that now. And then we're going to go ahead and answer some questions. So let's look at the questions. So A says, which function shows a constant rate of change in its y values, and how is this displayed on your graph? Well, that would be the first function. Y equals 2x has that constant rate because we're going up by 2 each time. And we should also notice that that function, that's my purple one right here, is linear. So which function, y equals 2x, and we could just say it's linear, okay? Which function is largest between 1 less than x less than 2, and how is this displayed on your graph? So looking between 1 and 2 on the x-axis. So if you think of it, actually I'll do a highlighter here. So x equals 1 is right here, and x equals 2 is right here. Okay, so between those 2 blue lines. All right, so I've got the purple, the orange, and the blue. And my question is, which function is largest? So in this case, which one is the highest up? So it's very faint, but it looks like it's my purple line right here. My purple line is the largest, okay? And it's a straight, that's the linear one. That's this one right here, which is a straight line. Which function is largest? And so that was y equals 2x. It is a straight line, aka linear. Eventually, which type of function shows the most rapid rate of growth in its y values, and how is this displayed in your graph? So looking here, ignore the blue lines. So my orange one gets the steepest first, right? So which one does that go with? That goes with this one, y equals 2 to the x power. So that one, y equals 2 to the x, shows the most rapid rate of growth, and it's exponential. It's that exponential function. Oops. So y equals 2 to the x. It is exponential. So anytime you're dealing with an exponential function, it is always going to exceed at some point a linear and a quadratic function. Exponential, anything that is growing exponentially exceeds anything growing linearly or quadratically. Now, if you look, like we said, between 1 and 2, the linear function had the highest, right, was the biggest. But that's only between that small interval, okay? Over the long term, your exponential function is always going to exceed the other 2. All right, let's look at the next page. So it says scenario 2. Consider the following equations. F of x equals 5x squared plus 4, and g of x equals 2 to the x. So before we can answer the questions, we need to fill out our table. So f of x, remember, is 5x squared plus 4, and it says that g of x is 2 to the x power. Okay, so I actually want you to pause the video and fill that table in now. So go ahead and do that, and then we'll come back. Okay, guys, So you should have your table filled in, just like mine. And now we'll answer a few questions. So let's look at part A. It says, as x increases, will the value of f of x, so that's what I've got in purple, always be greater than the value of g of x, which is in blue? So are the purple ones always greater? And what's my answer here? No, f of x is not always greater. It's not always greater because of starting, where is it? Right here. When x is 9, then f of x is less than g of x. So when x is greater than 8, right? When x is greater than 8, f of x becomes less than g of x, okay? Will an exponential function eventually always succeed a quadratic function? So g of x is exponential, and then the f of x is quadratic, right? So yes, the answer here is an exponential function will always succeed. Yes. Exponential will always trump quadratic at some point. Now, between 0 and 8 here, the quadratic was larger than the exponential, but eventually the exponential outperforms the quadratic every single time. All right, let's go to the next problem. All right, scenario 3. Consider the equations f of x equals 2x plus 3 and g of x equals 0.5x squared minus 3 and h of x equals 1.5 to the x power. We have some questions. You also see a graph and you see a table. So I want you to take a minute. I want you to do 3 different colors, one for f of x, a different for g of x, and a third color for h of x. Fill in the table and then use those same colors to graph each of those equations. So let's do that first. And then we'll answer the questions together. So pause the video, fill out the table and the graph. Okay guys, so you should have filled in the table and the graph with those 3 different colors. So you might want to pause the video real quick to make sure that your table and your graphs look like mine. So go ahead and do that now. Great. So let's answer these questions. So the very first one, question A, says, will the growth rate of g of x ever exceed the growth rate of f of x? So in mine, that's that purple, the purple and the blue. Well, if you're looking at the graph, we can see that right here, the blue is ending up getting higher, right, than my purple. So the answer is yes. G of x will exceed f of x. And we can see that that's going to happen right here when x is 6. And we can see that in the table too. So when x is 6, g of x and f of x have the same y value, right? They're the same. But as soon as we get higher than 6, my blue numbers are larger than my purple numbers. That's the simplistic way to think about it, right? So when x is greater than 6, okay, it will exceed. So yes, when x is greater than 6, then g of x will exceed or be greater than f of x, okay? B, will the growth rate of h of x, so that's my orange, ever exceed the growth rate of f of x? So we're comparing the orange and the purple. So if I look at my graph, when is the orange higher up than the purple? And that looks like it's happening right here. So at this point, when x is 7, they're about the same. So let's look here. I'm only looking at my orange and my purple. When x is 7, f of x is 17, and h of x is 17.08, which is larger. So if I actually go back 1, when x is 6, f of x is 15, h of x is 11.39, so h of x is smaller here, but as soon as we get larger than 6, then h of x becomes larger than f of x. So the answer here is yes, when again, x is greater than 6, then h of x becomes larger than f of x. And the last question for this scenario, will the growth rate of h of x ever exceed the growth rate of g of x? So on mine, I'm comparing my orange and my blue. So if I'm looking at my graph, when is the orange greater than the blue? And we don't really see that on the graph anywhere except for, well, let me back up. We do see it right here. Right here it's greater than the blue. And then we don't really see it again. So on the graph. So I'm seeing it is happening right here from 0 to 4. So let's look here. From 0 to 4, h of x is greater every time. Then it becomes smaller, right? Smaller, smaller, smaller. Okay, but then, so we've got here and here. This section and this section. So, yes, the growth rate of h of x will exceed the growth rate of g of x. So I'm going to say yes when x is less than, what did we say? As soon as x is 5, it switches, right? So when x is less than 5, and when x is greater than what? Did we say 9? Here, okay, here's where it starts switching again. H of x is at 38 and some change. G of x is at 37.5. And so when x is greater than 8. So when x is less than 5 and greater than 8, then h of x is greater than g of x. Okay, that's what we're going to say for that one. All right, let's go to the next page. All right, so our important takeaway, the graphs and tables of a function increasing exponentially. So write that word there, exponentially. Will always eventually exceed a function increasing any other way, right? Linearly or quadratically. Okay, so there we go. We've got that. All right, let's look at the next scenario. It says to use the graph below to answer the following questions. And so you've got functions A, B, and C. So I'm actually going to have you pause the video and do scenario 4 right now. So pause the video and do scenario 4 on your own. Okay, guys, so look over my work for this particular scenario. So pause the video, make any corrections. Go ahead and do that now. Great. Remember, if you've got questions or don't understand how I got an answer, make sure to see me so that I can assist you. All right, let's go to the next page. All right, so we have 2 more scenarios. So I actually want you to try these on your own also. So I want you to try scenario 5 and 6. So go ahead and try those, and then we'll come back and check. Okay, guys, welcome back. So now I want you to look over my work for scenarios 5 and 6. So here's scenario 5. So pause the video and check over that now. Okay, and then here is the work for scenario 6. Okay, guys, as usual, if you have questions about any of the work that I have done in this lesson, be sure to bring it to my attention so that I can assist you. Once you've turned this in, go ahead and work on your independent practice. Good luck.